Hi everyone, welcome back to VLSI for everyone. Today's topic is number systems and specifically we will focus on binary and hexadecimal, how to read them, how to convert them to decimal, how to convert binary to hex and where we actually use them in real VLSI work. Let's start with the binary number system. Binary is a base to number system which uses only two digits 0 and 1. In digital electronics, this makes perfect sense because the signal is usually either low or high, where we can map the lows as 0 and highs as 1. Every binary digit represents a power of 2. Now let's take an example of a binary number and try to convert it into a decimal number. So now let's take this number 1, 0, 1, 1. It's a 4-digit binary number. Now let's try to convert it into decimal. Since we know every binary digit represents a power of 2, let's try to map each of the bit of this binary number to a power of 2. So starting from the right hand side, we can map this as 2 raised to the power 0, this as 2 raised to the power 1, this as 2 raised to the power 2, and this as 2 raised to the power 3. Now if we want to convert it to a decimal number, we will just multiply each of the binary bit to its power of 2. So 1 into 2 raised to the power 3, 0 into 2 raised to the power 2, 1 into 2 raised to the power 1, and 1 into 2 raised to the power 0. So 1 into 2 raised to the power 3 is equal to 8. 0 multiplied by anything is 0. 1 into 2 raised to the power 1 is equal to 2. And 1 into 2 raised to the power 0 is 1 because 2 raised to the power 0 is 1. Now adding all these four numbers, we get 11. So a binary number 1011 is equal to 11 in decimal. So using this method, we can convert any binary number into a decimal number. Now let's move to hexadecimal number. Hexadecimal is a base 16 system. Hex uses 16 symbols, digits from 0 to 9 and then alphabets A to F. So A corresponds to 10, B 11, C 12, D 13, E 14 and F 15. Soon these numbers will be a muscle memory for you once you start writing RTL. Now let's take an example of a hex number and then try to convert it into a decimal number. So we're taking a hex number 2C. Like each binary digit represents a power of 2, similarly a hex digit represents a power of 16. So now let's start from the right hand side and denote each hex digit into a power of 16. So this corresponds to 16 raised to the power 0 and the next is 16 raised to the power 1. Now to convert it into the decimal, we multiply each hex digit to its power of 16. So 2 into 16 raised to the power 1 and C into 16 raised to the power 0. So 2 into 16 raised to the power 1 is equal to 32. And now since we are using C corresponds to 12. So now 12 into 16 raised to the power 0 is equal to 12 because 16 raised to the power 0 is 1. So we get 12. Now add both this number 32 and 12. 32 and 12 is equal to 44. So a hex number 2C is equal to 44 in decimal. Similarly, using this method, you can convert any hexadecimal number into a decimal number. Now, we have already seen how to convert a hexadecimal number or a binary number to decimal. Now we will try to convert a decimal number to a hexadecimal number. Let's take a decimal number 255 and try to convert it into hexadecimal number. Since we know hexadecimal number is a base 16 number system, we will divide 255 with 16. If we divide 255 by 16, you get a quotient 15 and remainder 15. Now take the quotient and again divide it by 16. Since 15 is not divisible by 16, we get a quotient 0 and a remainder 15. Now read the remainder from the bottom. It's 15 and 15. Since we know in hexadecimal number, 15 corresponds to F. So 255 in decimal is equal to FF in hexadecimal. Similarly, you can try to convert a decimal 83 to a hexadecimal number. Again, we will do the same. We will try to divide 83 by 16. Here, we get a quotient 5 and remainder 3. Now, if we try to again divide the quotient 5 by 16, since 5 is not divisible by 16, we get a quotient 0 and remainder 5. Now again, if you look from the bottom, the remainder comes out as 5 and 3. So 83 in decimal is equal to 53 in hexadecimal. Now if you want to check whether your answer is correct or not, we can again try to convert this hexadecimal to a decimal. Now since 53, now we can write it as 16 power 0 and 16 raised to the power 1. Now if we multiply 5 into 16 raised to the power 1 is 80 plus 3 into 16 raised to the power 0 is 3. So you get 83. This way you can cross verify your results. Now using this technique, this divide by technique, you can convert any decimal number to any number system. You just need to know the base number of any number system. Let's say if you want to convert 10, decimal 10 into binary. Since we know binary is a base to number system, we will divide 10 by 2. We get quotient 5 and remainder as 0. Now again you divide it by 2, you get quotient 2 and remainder 1. Now if you again divide it by 2, you get a quotient 1 and remainder 0. And if you try to divide it by 2, you get a remainder 1 because 1 is not divisible by 2. So now if you look at the remainder from the bottom, you get 1, 0, 1, 0. Now if you want to cross verify my answer, what I can do is I can write it in each bit in terms of its power 2. So 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2 and 2 raised to the power 3. Now if I multiply 1 into 2 raised to the power 3 is equal to 8 plus anything multiplied by 0 is 0 plus 1 into 2 raised to the power 1 is 2 and again 0 multiplied by 2 raised to the power 0 is 0. So I get 10. In this way you can convert any decimal number to hexadecimal or a binary number. Now coming to the hexadecimal to binary conversion, converting a hexadecimal to binary is very simple. Important thing to remember is each hex digit is equal to 4 binary bits. And how did I come to this conclusion? Because the highest value of a hex digit is F, which is equal to 15. And for 15 to be represented in binary, we need 4 bits. Hence, each hex digit can be represented in terms of 4 binary bits. And in this table, I have mentioned all the hex digit from 0 to F in terms of binary. Now, using the previous table, you can convert any hexadecimal number to a binary number. Let's take an example of A3. If you can see the previous table and see what does A corresponds to, so A is equal to 1010 in binary and 3 corresponds to 0011 in binary. And if you combine both this A3, you can easily convert a A3 in hexadecimal to a 1010 and 0011 in binary. Now, if you take another example, let's say 7F, and see what does 7 corresponds to in binary and F corresponds to in binary, and then combine it together, you can get the binary number. By using this method, you can convert any hexadecimal number to a binary number with ease. Now coming to the point, why I only wanted to discuss binary and hexadecimal in this video. Because in RTL design, hexadecimal is used far more often than decimal. Why? Because RTL and hardware deal with large binary values and binary number become very long and hard to read. Imagine you have a 32-bit register shown in binary. That will be lot of ones and zeros, and it will be difficult for you to understand and more prone to making an error. But the same value in hexadecimal is much shorter and easier to understand. Now let's take an example of a 16-bit register whose value is 40,000 in decimal. Now, if I convert that 40,000 in binary, it will be a lot of ones and zeros. And if I have to write it in binary terms, I can make a mistake with any one of the zeros or ones, and it will be hard for me to quickly see whether I have made a mistake or not. Whereas if you represent the same number in hexadecimal, it is very compact and shorter and easier to read. Now you can also ask the question why we are not using decimal. Because if I give you a large decimal number and ask you to convert into binary, or give you the same large number in terms of hexadecimal and ask you to convert into binary, which one will you do faster? I'm sure your answer will be hexadecimal. That is why for binary representation in RTL design we use hexadecimal, because it is much shorter, easier to read, and you can quickly calculate the binary number through it as well. That is why in our RTL design or in digital design per se, you use binary, which is most important, and then you use hexadecimal. The main advantage with hexadecimal is that one hex digit represents 4 binary bits, which makes it very easier to convert hexadecimal to binary or binary to hexadecimal. Why hexadecimal is so important in RTL design? So when you look at the register values, memory addresses, test bench output, waveform dumps, or machine codes, you will often see them in hex format. That is why as soon as you move into RTL design, hexadecimal becomes one of the most powerful number system to the engineer. And to summarize, hardware speaks binary. All digital circuits operates in zeros and ones. So understanding binary helps you see exactly what the hardware is doing at the signal level. But hex makes the large data readable. Binary gets too long, especially if you have to deal with 32 or 64 bits. Hex compresses it, so it's much easier to read, write, and debug. And always remember the mantra, 4 binary bits is equal to 1 hex digit. Hex and binary is used everywhere in RTL and DV. You will constantly see the use of hex and binary in writing test benches, debugging waveforms, memory address and registers, and bit masking and shifting. So if you're starting your journey in RTL design or VLSI, do not ignore hexadecimal. Learn it well because it will save you time and make digital design much easier to read and understand. Thanks for watching and subscribe for more content.